In this video, we will look at how can we use graph to examine assumption 3. The population of the arrows or residuals is normally distributed with a mean 0. As I mentioned in the first video for this series, and I said for assumption 3 we need to use two plots to examine this assumption, because in this assumption they list two important information. The first is normally distributed, the second is a mean 0. So we need to use a separate graph. One is to test the normally distributed, another is to test a mean 0. So first, let's look at how can we test the mean 0 assumption. So for the mean 0 assumption, actually we will use the plot we already created. It's called the residual against our. We will use a residual against our predicted y value. So now what you can see on the screen is under what condition we will think the assumption 1 or assumption 3 is not violated. So if you look at this scatter plot, and you can find that the point should be distributed about the horizontal line 0. So first you can find this horizontal line, and all those dots is our residual. They are evenly distributed around this 0 horizontal line. So you can also see any pattern based on this plot. So we've already know how can we create the residual against our predicted y value. So now let's just go back to quickly look at the plot we just created. Residual against the predicted y value. So we created this plot in the previous video for testing assumption 2. So obviously we can find for our residuals, they are not evenly distributed around this 0 horizontal line, because you can find the spread for the residual are decreasing, and when we reach to the largest point is 4.0 GPa predicted value, and we only have one observation is here. So the residual is not evenly distributed around this 0 line for these specific cases. Then let's look at how can we test the normality assumption. In order to test the normality assumption, we will use normal probability plot. So in this case, I'm showing you on what condition we will think the assumption 3 normality assumption is not violated. So this is our normal probability plot, and the Excel will give us once we do the regression analysis by checking those 5 boxes. And the last box is about normal probability plot. So why we think this graph showing us the assumption is not violated? Because the points are all following the straight line. So you can find all the lines are straight-lined. So now I want to show you some special cases when we will think the normality assumption is violated. So in these 3 different cases, we found assumption 3, normality assumption is violated. So first, if you look at this one, majority of the dots are in the straight line except this one. Even we have one dot outside of this straight line, we will think assumption 3 normality assumption is violated. And how about this one? So obviously this one you can this one and that one you can very easy to find not all the dots are in the straight line. So now let's go back to look at our Excel example to see where we can find this normal probability plot. So actually we don't need to really draw this normal probability plot. What you need to do is we need to go back to our original file and find there is a plot just called the normal probability plot. So let me enlarge this plot. So what you can find for our example is actually they are not perfect line, right? We have some dot up and it's not in this very proximate to a line. So this can happen for our small sample size with only 7 observations. If we have like more than 50 observations, this pattern will be more obvious. So in this case, we think normality assumption is violated because these dots are not in the straight line. So the assumption 3 actually in this case is also violated because both mean 0 and the normality are not satisfied.